Okay, so we looked at how to speed up first meaningful paint. Now we can move on to the next metric, which is time to interactive. And as you might recall, this is the point at which the page is actually usable and doesn't just appear that way visually. There's a delay in most sites between when a page looks ready to use and when it's actually interactive to touch or click or keyboard interactivity or screen reader use. And I want to emphasize that if you follow the tips that led up to this point, time to interactive should be a less problematic metric for you to get right, because you've likely delivered content that's useful at initial render without waiting for JavaScript dependencies to load and generate it. And that's great, but it's not always that simple. Modern JavaScript frameworks have introduced a new challenge to that assumption that we should address. And that's because many modern frameworks are built to treat the HTML they first deliver as a sort of performance step, but not necessarily a usability step. So if a site that's built with, say, React starts by rendering HTML on the server, they usually re-deliver or replace or rehydrate, as they call it, that content to make it interactive. So the initial HTML is more for an early rendering of appearances, but it may not be useful yet until the JavaScript ends up loading and rehydrating it. So that rehydration can mean a non-operable site for a brief period, and it's illustrated kind of literally here in an article from Adi Osmani. You can see that gap where you've got the page that was delivered, and then the JavaScript churns, and then it becomes interactive. Now, for these frameworks, this effect that we're seeing is actually an improvement, because traditionally, and still today, they tend to lead with the pattern of generating content entirely after the JavaScript arrives in the browser. So there's nothing from the start, and then suddenly there's something. And that's not progressive at all. That's not a good performance pattern. So frameworks began rendering on the server to address that. But this new pattern is also perhaps worsening real-world performance overall, because showing a page sooner might make it seem as though overall performance is doing well, when it's actually taking much, much longer to make the page interactive than it was before things looked rosy in this new progressive pattern. It was harder to hide how long it took for a page to become interactive if the page was blank the entire time until it just appeared and became interactive. So this is a good pattern, but it can be a dangerous pattern. Netflix noticed this problem in 2017 with their React site. They were server rendering, but they were still experiencing delays due to React's client-side rehydration time. So they decided to remove it, favoring prefetching the JavaScript for future pages that you would visit on Netflix, but not the first one that you use when you initially arrive. And they saw a 50% reduction in their time to interactive because there was just a lot less JavaScript running on the client. And the problem with this metric is not only seen in modern JavaScript frameworks, it's just that those happen to ship a great deal of state and behavior in JavaScript. If you recall this animation from the metrics section, it illustrates the frustration of this delay pretty well, and it occurs on sites that aren't running on React as well. So this is a good time to mention that we actually have another metric that sort of deals with this delay between our time to largest contentful paint and our time to interactive, and that metric is called total blocking time. And you'll start to see this show up in some tools, particularly if your numbers for this metric are egregious enough for it to be elevated. You can see in web page test here at this CNN result, we've got total blocking time right here. So again, that's the delay between when the page is visible and when it becomes interactive. So not the full time to interactive, but actually that period where the page is being enhanced or rehydrated. So look out for that metric in the tools that you use. Adi notes that we should be aiming for interactivity in under 5 seconds on a slow 3G connection on a median mobile device. So 5 seconds total to the time when we can interact. And again, the median device is the one that can take 6 seconds just to parse 200 kilobytes of transferred JavaScript. So if you're using a framework for client-side JavaScript, this can be a really hard target to hit. So what can I do to improve this metric? Well, A huge and probably obvious thing is to find ways to rethink our dependency on JavaScript in the browser. Yes, a bit of JavaScript is crucial to most great experiences on the web, but there are plenty of ways to think about architecture that allows us to use less of it. Chris Fernandini runs a course called Vanilla JavaScript Academy, and alongside it, he has this great resources page for JavaScript APIs that we can use in the browser today without the need to depend on library code. It's a really great site. I love the methods and APIs page because it's organized like a classic JavaScript library. So if you're familiar with something like jQuery, you'll be surprised to find how much of that sort of workflow now requires no library at all. It's really neat. It'll be in the resources section. Also, in your journey to using less JavaScript, a hugely helpful thing is to lean harder on native HTML and CSS components, especially highly functional ones like form controls, because those can get quite complex if you're trying to handle all of the logic in JavaScript. A simple example, it's common to use JavaScript and custom markup to generate form controls like a drop-down select menu, perhaps due to challenges in matching the way you want the select to look. But in many cases, native HTML select elements are quite stylable today. And I covered that in this article, Styling Select Like It's 2019. I actually wrote this in 2018, and I'd still recommend it in 2020 and even later. It basically shows how far we can take it today to get really consistent and attractive select elements across browsers today. This is custom CSS applied in just a few of the many browsers in that article. So this is just a sampling, but there's no JavaScript needed for things like this. So this sort of process of weighing the benefits of going fully custom is important to consider because mimicking the behavior of a native form control requires a great deal of thought and planning, particularly when it comes to accessibility and usability. So the amount of JavaScript required to, say, make a custom select element, that may mean a huge hit to performance in order to do it well. So you really have to evaluate that trade-off and make sure it's really worth it to your users. And generally, we want to be aware of new CSS features that we can use to lighten our JavaScript load. For example, CSS lets you make scroll snapping regions now to create carousels with no JavaScript at all. And you can start with that to build more sophisticated controls on top of that to do a little more, but at least the foundation is not using as much script as we used to need to do this sort of thing. Of course, if you're already dependent on a large JavaScript stack, it's not easy to just rebuild in less JavaScript dependent ways a lot of the time. Fortunately, there are tools to help us break apart and reduce the JavaScript that we're delivering. First-party JavaScript tends to be more purposeful and often reasonable to break apart with good tooling compared to the third-party scripts that we pull in that are sort of a black box. So when dealing with our first-party code, tools like Rollup can analyze the modules in our JavaScript that we're using and create a build that ignores the portions of JavaScript that are imported but never used. And this is called dead code elimination or tree shaking, and it can save a great deal of weight depending on whether or not you use the methods that your framework imports. So this can help a lot. Rollup's a great tool for that. That's a build tool. Webpack and other tools offer tree shaking in similar ways. They also offer workflows like code splitting, which allows you to split your code into various bundles, which can then be loaded either on demand, so not upfront, but when they're actually needed or requested by the user, which, if used correctly, can have a major impact on your loading time. So you should look into Webpack code splitting. Of course, these examples use fancy, sophisticated modern tooling, but the idea isn't really all that new. Recently, I did this on a client site with less sophisticated means. I noticed that the reviews widget on the bottom of a product page on a site we were working on, which was provided by a third party, was quite heavy, and simply including it in the page was causing interaction delays of many seconds on some common devices. So shown here is an example widget like that one on a different site, but in our user interface, the reviews weren't even visible by default. They didn't even show until the user clicked a reviews button to expand them. And this seemed like a really great opportunity for performance to me if we deferred the load of that feature entirely, either by waiting for the user to click that, or at least loading it at a later time after the page was enhanced and the CPU calmed down. It made the initial page load experience a lot smoother, and the time to interactive came much sooner, at almost no cost to the perceived visual experience. Of course, if you're writing the JavaScript yourself, there are likely opportunities to optimize how it runs as well. Browser dev tools have great panels for profiling JavaScript execution, where you can see which functions are taking the most time and the most memory, so you know where to focus your performance improvement. The more you can chunk up your JavaScript so that it doesn't all run at one time, but instead asynchronously as it's needed, with careful breaks to offer to the CPU, the better your site will perform during runtime. It'll have a much smoother frame rate. So it's good to look into these tools and see what's bogging things down when you interact with your site. What are the heavy, intensive functions that are being called? And then you know where to focus. And when you're using these browser tools, be sure to throttle both the network and the CPU so you can get a better look at what is taking the longest. If you throttle down and kind of focus into a section of a recording that you did, you can see the functions that are called in order of the time that they took, and then you know where to focus. And this kind of optimization contributes to a metric known as first input delay, which measures the time that it takes for a UI to respond to user interaction. First input delay is gaining priority in performance initiatives like the Web Vitals project that I mentioned earlier, and it factors into scores for, say, Lighthouse, which in turn gives you a good idea of how fast your site will be considered, both to users and, say, to search ranking algorithms. So check out first input delay. That's a really important metric for measuring your interaction time on your site. And those runtime benefits can help us to get an interactive page sooner as well. So in doing this work, we can look to browser functions to help us do this, like request idle callback, which is a kind of more sophisticated successor to older approaches like set timeout. This function lets us defer to the browser for an optimal moment to run code when it's idle, either whenever it likes or within a given time frame. So code like this helps us help the browser manage its tasks more efficiently and decrease interactivity delays. Another similar method is request animation frame, which has less to do with decreasing time to interactive, but it's along a similar line of thinking, I think, where we offer the browser a function to run at an opportune time. In this case, for anything that runs visual animations in JavaScript that ends up painting to the screen. So this idea of deferring to the browser when we can will help with delays and general delight in how a UI functions. And there are so many other APIs to consider that allow us to tax the CPU less. There are many modern APIs that are a more performant take on patterns that we've been doing for quite a long time. One of those is Intersection Observer. This API lets us observe elements as they come in and out of the viewport in a more performant way. So if you've written listeners to listen for scroll events or resize events, and then look for elements in the page and see if they're within the bounds of the viewport or not, this API is a much more performant way to handle that logic. So generally with interactivity, that's something we just want to keep in mind. How can we lessen the load of JavaScript that's running at any given time, particularly when the user is trying to interact with the page? So that's about all I wanted to cover for time to interactive. It's obviously a really complex subject when you're actually optimizing the JavaScript that runs on your site, but those are some just basic tools that you can consider to start to analyze and optimize the script that you're already running. So again, lean harder on native browser features that get you farther along to an enhanced experience with less JavaScript involved. Break apart your scripts so you're loading only what you need when you need it. Make sure that you're eliminating any scripts that are not being used so they're not loaded at all. And then optimize how the scripts that you must run are going to run in the browser so they're much gentler on the CPU and the time to input delay is very, very low.